Hi, today in Unreal Engine 5, we will polish this power-up animation using particle effects and overlay materials. Before we start, let me give you a quick overview of what we are dealing with here. I have created a third-person project with starter content. Then I imported this animation into Unreal and made an animation montage. Created an input action to trigger the power-up animation. Add it to the input mapping context and I am using the F key. And in the third person blueprint, when I hit the F key, I play the montage we created. That's all I have set up here. If you would like to see everything step by step, you can find an extended tutorial on my Patreon page. So let's start with an overlay material. I make a new folder here and call it Power Up Effect. Inside it, I make a new material, 𝒚_power_up overlay. Open it, search for Fresnel node, add it. You can right click and select Start Preview to see the changes in the preview window. I set the exponent in to 0.5, this to 0.05. Then add a power node, plug this and set this to 5. Let's plug this into opacity. At the moment it grayed out, so select the big node and here set the blend mode to translucent. Then add multiply node, plug this and set the second value to 10. This will be our emissive strength. Hold 3 and click to add color node. Add another multiply node like this, plug its output into the emission color. And I give this an orangish color. I stop the preview and here is the overlay material. We are going to add this to our character. Save the material. In the third person blueprint, when we trigger the montage, I drag from here and add set overlay material node and select the material we just made. Now if I hit play and press F, we are adding the overlay material on top of the mannequin material. But I want to time this using the animation montage. So open up the montage. I scrub the timeline and pick a place where I want the overlay material to trigger. About here. Under notifies, in the first track, I right click and add notify montage notify. I rename it to overlay M. Back in the blueprint, when the notify begins, I set the overlay material. Remove this connection. Then I duplicate this and when the animation is complete, I set the overlay to none. Now if I play, you can see it sets the overlay at the time we pick and removes it once the montage is complete. Now let's move on to make the Niagara effects. I right click here and choose Niagara system. Select this directional burst, hit create and I rename this to NS power up charging. Double click to open. You can see here we have a bursting particle effect. Let's change some settings to make it into an absorbing or charging effect. So in the emitter state, I set the loop duration to 0.5. In the spawn burst instantaneous module, I keep the particles spawn amount to 75. Here in the particle spawn, we can set some values for particles to start with. So in the initialize particles module, I set the lifetime min and max to 0.2 and 0.4. To spawn the particles around the character, I click this plus button and select shape location. Set the shape to sphere and radius to 200. In the add velocity, change the velocity mode to from point and to absorb the particles towards the center from the spawn location, I set these values to negative numbers, negative 250 and negative 400. Then I disable gravity, drag and scale color. Make sure to put the shape location module above the velocity module to see things correctly. Now you can see we have points going towards the center. Back in the initialize particle module, I set the color mode to random hue saturation value, uncheck hue change, check value range, and set min and max to 80 and 100. Now we have some glowing particles. For the color, click this arrow and select random range linear color option and set the two colors as you like. Here I went for something yellow and orange. Also here we can set the initial sprite size. I set the minimum X and Y to 0.5 and 7 and max sizes to 1 and 20. Enable the drag and set it to 0.4 and 0.6. This will add some resistance to particle movement. Enable scale color. In the scale alpha, it reduces the sprite opacity over time. I keep it like this. Select the emitter F2 to rename and I call it charging particles. Also, here in the properties, I set the sim target to use the GPU. Set bounds to fix. Now back in the content browser, I right click and duplicate the Niagara system. This will be our release effect. I rename it to NS power up release. Open the power up release Niagara system, and here I change a few values to get a bursting particle effect. This one going to last longer, so I set the loop duration to 1. I increase the particle count to 1000. Change the velocity to 450 and 800. We need a big burst. Set the lifetime to 0.4 and 0.8. I keep the color the same, but I increase the value of glowing strength to 150 and 200. Increase the sprite size to 1 and 10 and max size to 2 and 30. For the sphere radius, I decrease it to 50. That way it starts closer to the character. Reduce the drag to 0.1 and 0.3. Save this and let's go back to the montage to set these to Niagara system. I add a new notify track. Call it NS for Niagara system. I go to the place in the timeline where I want to trigger the charging up effect. I pull this window up a bit. Right click, add notify, and this time choose play Niagara particle effect. Now select the notify and select the Niagara system we created from here. Hit play and you can see the particle effect with the animation. I want the simulation point to be up here near the character's chest. You can offset the simulation from the Niagara system itself, but I'll do it from here. In the location offset, set the set to 100 and X to -10. Similarly, pick a place for the release effect, add notify. Select the release particle system and change the simulation location. Just like that, we have added 2 Niagara systems to the animation montage. You can always adjust where the notify starts to change the timing of these effects. We got the basic power up effect working. Now let's add a few more things to polish this. First, I'll add a heat distortion effect to our charging Niagara system. So I hit Ctrl D to duplicate this emitter. I increase the loop duration to 0.6. Double the spawn count to 150. Set the color to direct set and click this button to reset it. We don't need to worry about the color for the heat distortion. I increase the lifetime to 0.4 and 0.55. Sprite size, I change the mode to random uniform and set the min and max to 60 and 100. Now here in the sprite renderer, I change the sprite alignment to unaligned. Also disable this scale sprite size by speed module. I keep the drag and scale color as it is. For the velocity, I change it to -350 and -500. I increase the shape radius to 300. for the material, I'll use one from the starter content. So here in the starter content, particles, materials, we have this heat distortion material. Double click to open it. In order to see it in the preview, we have to set this dynamic parameter value to something above 0. I set it to 1. That way we are getting this maximum refraction of 1.5. Go back to the charging effect, and here in the sprite renderer, select the heat distortion material. We can't see anything. That's because we have to set that dynamic parameter value from here in the emitter. So click this plus button and search for dynamic material parameter. Here for the first parameter input, I set it to 1. Now back in the montage, you can see the refraction happening, the heat distortion. I think a value of 1 is too much, so I set it to 0.5. Also, I like to change the sprite size over time. For that, instead of speed module that we disabled here, I use scale sprite size module. By default, it starts small and gets to full size during its lifetime. I want the opposite of it, so I select one of these templates. Let's select this and adjust this handle a bit. I think that's enough for the charging effect. For the release effect, let's add some particles that spawn from the character's mesh. Particles like fire embers. In the power up release Niagara system, add a new emitter, and this time I select fountain. I disable the gravity for now. You can see right now they are spawning from a sphere surface, but as I said, I want them to spawn from the character mesh. So I delete this and add skeleton mesh location module. Put it above the velocity. Then change the source mode to attach parent. That way emitter will use the parented skeletal mesh as the spawn surface. For the preview and for the default mesh, I select our queen mesh. Now if I disable velocity, you can see the particles spawning from the skeleton rig instead of the surface. So for that, here in the sampling, I set this to use surface triangles. And here I get an error, hit fix now. You can see we have particles appearing from the mesh surface. Now let's change some values to make this look like embers. Set the loop duration to 1. Here for the spawn rate, I set it to 1000. We have more particles now. For the lifetime, set them to 0.4 and 1. For the color, we can use the values we used earlier. So here in the first emitter, I right click here and select copy and come back to Embers emitter and paste it. It didn't copy the whole thing, so let's copy this and paste it here for the color. I disable hue change and set the values to 150 and 200. Our ember size is too much, so I reduce these to 0.5 and 1.5. Also, I feel like lifetime is too low, so I set the max to 1. I set the loop behavior to multiple and count to 2. Keep the velocity disabled and enable the gravity, and I add positive 50 on z-axis. This will accelerate the particles upward. For adding noise to the movement, I add curl noise module and set strength and frequency to 100. I increase the drag to 0.5. I set the emitter to use GPU and fix bounce. Let's see how this looks in the game. Let's add a few more emitters. This time I choose directional burst. I call this one particle collision because these particles will fall down and collide with the ground. I change the spawn count to 250. By the way, you can click this button to isolate the emitter. For the lifetime, I set it to 1.5 and 3. For the color, just like before, I copy paste from the previous emitter. Set the value to 150 and 200. For the size, I set the mode to random uniform and set the min and max to 1 and 3. Again, I add skeletal module. Set it to attach parent and select the skeletal mesh and set the sampling to use surface triangles. For velocity, change it to point and set it to 100 and 200. I reduce the gravity to -500. Drag to 0.1 and 0.3. To add collision to the particles, I add collision module. Set the bounce to 0.2 and friction to 0.1. And that's it for this emitter. Let's add heat distortion to Embers. I duplicate the previous Embers emitter. Let's name the first one to Embers and this one to heat distortion. For this one, I reduce spawn rate to 200. Increase the lifetime to 0.5 and 1.2. Size to 25 and 30. Reset the color. Enable velocity. To add slight upward movement, set this to linear and add a set velocity of 50. Drag to 0.4 and select the heat distortion material for the sprite renderer. Add a dynamic parameter module and set the first value to 0.5. You know what, let's change this a bit over time. I click this and select float from curve. We can change the parameter value based on their normalized edge. I keep the curve like this. Let's see this in action. You can see a bit of distortion around the embers. Let's add a light. I add a new emitter. This time select this single looping particle. I call this one light. Emitter state to self and set the duration to 2. Spawn burst, keep it at 1 particle. I set the color to direct set and select an orangish color. For the value, I type like 150. That will work as our emission strength or light strength. I set the sprite size to 50. Right now you can see the particle here, but because of the simulation offset we added from the montage, this will take place around here. It is rendering as a sprite at the moment, but we can click this plus and add a light renderer. This will cast light onto the surrounding from this particle. I can enable the flow for the preview from the preview scene settings. If you don't see it, enable it from the window menu. I enable show flow and disable sprite renderer. You can see a tiny bit of light casting here. Let's go to light renderer settings and disable use inverse square law follow. Increase the radius to 3. Now if you play, we have this light casting. To smooth out the sharp edges, I change the default exponent value to 3. Also, I enable this alpha scale brightness. This will affect the light brightness based on sprite opacity. So to change it, I add scale color module. And here for the alpha, I select float from curve. I choose this template. Select the second point and set this to 0.1. In order to do light rendering, you have to use the CPU for the emitter. You can see the light fades in and out. Let's add a light renderer to our collision particles as well. So here in this emitter, I add a light renderer. We are already in the CPU. For the light renderer, I use inverse squared follow. Enable alpha scales brightness. Radius to 2, and that's all for the effect. I'll change the environment light a bit so we can get a better look at our effect. And here is our power up effect in UE5. You can implement this to your game however you like. Here we trigger the montage, trigger the particle effect. I got a few UE5 Niagara system tutorials in the channel. If you're interested, go ahead and check them as well. Thanks for watching, and I'll see you in the next one.